So on this 2005 Acura MDX, having a hard time finding a leak. Now in the first video, this is video number 2, I used the high pressure nitrogen and the ultrasonic leak detector. And I was able to kind of get it roughly down in an area, but I could not pinpoint it. So I ended up putting refrigerant in it, and I had to do that anyway because I needed to test the compressor, test the operating controls, and make sure all the functions work correctly. I'm also trying to use, as you can see right there, you can see me moving inside the monitor, trying to find down where this leak is happening from. So far I can't use the UV dye, is not getting it. Let's look at the temperature, but while we're running here, I have it full. Let's look at these temperatures here. This is the rear duct. This is the front. There's 2 evaporators. This is a dual air conditioning system. Look how cold the rear air is getting. Let's keep watching that. The return is the rear air duct with the rear evaporator. The front is the front air supply. Now for those of you with experience, you know usually the rear is warmer than the front. Let's see how cold this gets when we get down there. Should be kicking off soon. Well, it gets really cold. I don't have time to watch grass grow, but as you can see, there's where I'm taking the front, and you can see the other door is already open. Here I have this door open, I have it on front air. That's where I'm taking, there's another evaporator in this rear case back here. So we can see it's getting close to 32 degrees, I think, when the compressor cuts out, at about 32 degrees. Now there's a reason why this rear evaporator is getting colder than the front evaporator. The clue is, let me see, what do you see right here? Dog hair. They vacuumed, I could tell they vacuumed this before they brought it here, but there's traces of dog hair everywhere. There we go. You see all that dog hair? Well, that's a clue why the rear evaporator is colder than the front. You go, how does dog hair make a rear evaporator colder than the front evaporator? Well, it appears the dogs are back here. There's a short hair and a long hair dog. There's 2 dogs because there's 2 different lengths hair. So look inside these vents, dog hair. And where does this pick up the air, the intake? Right here. So there's barely any, there's airflow, but barely any airflow. I could hear the fan on high speed. I got it all the way up on high speed. I got it on fresh air vent. The vent or the evaporator is all plugged with dog hair, or the fan blades are plugged with dog hair. So it lowers the air output, so you get colder air. But colder air doesn't mean better cooling because you have less volume. So there's less mass. Imagine a football or a baseball, or let's see, what's a good square? A square foot of air floating in the air. Let's imagine basketballs. We have these basketballs. So instead of, let's say CFM, we're going to say instead of 500 basketballs shooting out across the evaporator, getting cooled down to say 47 degrees, instead of 500 basketballs per minute, we're only having 80 basketballs per minute coming out of that vent, but they're 32 degrees. There's more cooling in that warmer cubic feet of air coming through this vent at 48 degrees at 500 basketballs, and there's 80 basketballs coming out there at 32 degrees Fahrenheit. I got to say Fahrenheit because we're over here in the US, not Celsius. So that's what's going on there. We have a plug with dog hair up front, and I'm pretty sure in the front too, because I see the dog hair here, and there is a cabin air filter. I'm bet to sure, and looking how dirty that outlet vent is, I bet you they haven't changed that cabin air filter either. So that's a totally different issue, having nothing to do with the leak out here, but that will cause a cooling problem, because if you have air restriction in your front cabin filter and you have air restriction, even though you can have 32 or 38 degree air coming out of your front and rear vents on a hot day, the volume of air, the mass of air is too low, even though it's very cold, to cool off the cabin or the environment. It'll only feel good on your hand, but it can't compensate for the mass of air. So I'm going to shut this off, and I'm going to search with the leak detector because I have it full now, and we're going to see what we can find with the leak detector, because I'm having a hard time pinpointing this one. Now, I have it on cloud hunting mode. Let me turn off the vacuum pump. We don't need that. Oh, thank you, my ears. Okay, so cloud hunting mode is a slower mode, but it's very sensitive. Oh, we're picking up something right now, are we? So let's get over here. So we know this is a big leak with high pressure nitrogen at 175 to 150 psi. What is our pressure right now? So now we have refrigerant in the system, and that means timed out. So that means so on the high side we have 108 psi. So if the leak is on the high side, it's exposed to this pressure. On the low side we have 48 psi. Now compared to my dry nitrogen, where I drove it all the way up to 170 or 75 psi, it's a little bit of a difference. So let's see what we find coming down here now. Well, the ultrasonic leak detector was just screaming in my ears with the headset, and you were able to see it with the light bar. And going all the way by the compressor. I know we're right in here somewhere, because the ultrasonic leak detector was just screaming. Let's get by the front chassis. I'm pretty sure when I was taking the ultrasonic leak detector by the front chassis of the compressor, the noise went down. Let's look at our parts per million. Nothing. We're picking up nothing in that area, but yet the ultrasonic was screaming. Let's get down here by okay. Let's get behind it. Let's get up here by the upper fitting. Is right here. That's the upper fitting. We can see we got a lot of water coming out the bottom down there. Okay, what happened to the leak? Where did it go? Why is there no leak? So let's go to the other mode, because it's going to say, oh, you're in cloud hunting, and that's slower than if you were in the other sensitive mode. Okay, so let's go back outside so we don't zero out and change modes while we're by. If there is gas in there, I want to do this. Okay, we're in super right now. We're in the highest sensitivity, faster acting mode. So let's go back out there. Okay. And we're just kind of hunting around, because we know this is a screaming leak with the nitrogen. And we know it was really screaming and going off right as I pointed right down in this area. Let's see if I could get some more light on the subject here. There we go. Now, with that scream of the ultrasonic leak detector getting me down inside here, there is nothing. So what I'm billing a bet, either a hose got hot or cold, or metal got hot or cold, and the leak is now gone. It is sealed. It is completely and utterly sealed. But to make sure of that, let's go get, and I have dye, I have UV dye in here too, so let's get a UV light. Now, of course, I don't have the flash, the mirror, and I'm not going around. I'm looking for drips. I mean, that thing was screaming so loud with the ultrasonic that you go, oh my God, it's in, you can see my dye right there. Okay, and you can see where some of my dye spilt on the side of the pipe right down there. You see the pipe going way down there? I got a drip there. That's my spill. So let's go back to the ultrasonic leak detector. Sorry, I took the ultrasonic leak detector away and turned it off. I should have kept it on and kept it, let's get this. Let's turn it on. Okay. So now we had a screaming leak using nitrogen. And now we have refrigerant in the system. Oh, you have to turn off your leak detector. Look at this. I see guys doing videos and they're looking for leaks and there are things always going off. And they have one or two of these on in the background. Well, you see that little hole right there? That little hole, you can actually hear my speakers. Here, let me turn my speakers up this way. So there's the speakers for my ears, my headset. There's the vacuum leak because there's a pump sucking air here. Now, watch this. Let's look at the meter. Okay, it's picking this up. Watch this. You hear that? That's what I hear in my ears. Okay? This is why when you see the guys using this piece of equipment, but they have one of these on in the background, and you see their meter flipping around and they're looking for a leak, you have this big vacuum leak created right here. And I've seen some really good YouTubers I have a lot of respect for. They do really, really good work. They're experts in their field. They have a lot more knowledge and experience than me on training and everything, but they don't know the limitations of their equipment and the problems it causes. Okay, so now look at it. You see how it stays steady? That is the difference between somebody who knows how to use a piece of equipment and somebody who doesn't. You do not have a leak source like a vacuum pump on in the background when you're trying to use one of these. Where's the leak? Remember how this was screaming in video 1? Now every time you see that go off, I'm either talking or I move. Watch this. Okay, I gotta show you how sensitive this is. Do you see that? So if you're even holding this in your hand and your arm hairs, the hairs on your arm brush against something just like this, the sound travels in your hand to the microphone and it picks it up. That's how sensitive this is. Now remember before, when I was doing in video number 1, I came out here from a couple feet away and I just held it like this. Okay, so either I'm picking up a leak or it's the background noise because I could hear cars with rolling tires out there. I got the wind blowing and you could have sound bouncing from outside under the car coming up because high frequency sounds are extremely directional. So I'm gonna put these on my head and go from underneath so I could listen. And let's take my hat off. Don't need the hat. Nothing. Now watch this. The sounds from outside off the concrete. Nothing now. See where I'm shooting and just touching this like this sets it off. But you see this hole right here? Nothing. Just me moving it. Absolutely nothing. So, right now, at this moment, filled with refrigerant, it was operating, moving, has UV dye in it. Using the electronic leak detector on either cloud moding or on its most sensitive hunting mode, nothing. Using the ultrasonic leak detector nothing. Using the UV dye, nothing, okay? But yet, when we had high pressure nitrogen on here and the vehicle was cold and sitting, wasn't ready for, we had a gusher. The thing was just howling. So, now that I know it, because I just put a preliminary, I didn't measure in the refrigerant, I was just testing it for looking for this big leak that was howling. And when we were doing a nitrogen pressure decay test, it dropped from 175 down to 140 psi in about 14 minutes. So we just went over a very, very cold air temperature coming out of the dash due to clogged airflow from dog hair clogging up the vents. We went over the fact in video number 1 that the ultrasonic leak detector was picking up a howling leak coming out of here. You can't hear it with your ears. Oh, and I used it. Where's the bubbly leak detector? Did I show you that? Shoot. Yeah. So I also used the bubbly leak detector, and I sprayed everything with the bubbly leak detector down under there, and I went underneath the car, and I used the bubbly leak detector. Nothing. So I picked it up with this, but I didn't zero in on it. I used UV dye, didn't find it. I used electronic leak detector, didn't find it. Only the pressure decay tester indicated it, but it wasn't audible to the ear, and only the ultrasonic leak detector clued me on to the area, but I didn't zero in on it. So this is a winner, other than I didn't get to pinpoint it. This is a winner, both using nitrogen. The loser in this battle is the UV dye didn't show anything, and the electronic leak detector did not show anything with refrigerant in it after the system was running. The leak is 100% stopped now. Not even this can pick up anything. This is where you got to know, some leaks turn off and on. We're dealing with metals that expand and contract with temperature, and rubbers that expand and contract with temperature, and an oil film over like a crack or something. So let's get off to the next one. I got to evacuate this down. I'm going to hit it again and try it one more time with nitrogen before filling it off with refrigerant and just telling the customer to take it. Clean everything off down here. Looking for oil sources. The only oil sources I was able to find were the ones coming from the fittings, where you see oil on the lines over there coming out of the fitting, where like the valve cores were leaking, having nothing to do with what's over here. Totally isolated in different areas. There was no howling from nitrogen over here. It was from down here. So I'm going to change the valve cores, recover the refrigerant I have, evacuate it, and recharge it. And if I don't find a leak by that time that I know there's a big leak in here, he only came in with 9 psi, then I send him on the way and let him drive, tell him to use his AC, even if it's raining, even if it's snowing outside. Keep your AC on, but adjust the temperature and your vent blower to your comfort, but keep that AC light on. Keep it in defrost mode, whatever you want. Just adjust the temperature to your comfort. And the idea is to keep the UV dye circulating. Guys in commercial HVAC and residential hate UV dye, because usually you could find it because you have good access to everything, and they don't have to worry about rubber hoses and seals that turn on and off leaks at different times and vibrations and pressures. They just have metal that could expand and contract and stop a leak. So that's what I'm going to do. I'm going to recover refrigerant, properly charge it. If I don't find a leak, which I know it's right down here, if I don't find a leak, I'm on the rack right now. Here we're at the rack. I'm going to pull it forward, pull the pan off from underneath, and look up above and see if I can find a leak. But other than that, then this gets shipped out with a charge of refrigerant in it, with dye in it. Customers ordered to use the AC for the next few days, continuously, non-stop, make this his daily driver, and then bring it back. And you know what? Sometimes I've seen these kind of leaks just stop for months, and it was howling, and it could not pass the nitrogen pressure decay test, and then it stops leaking for months. Or tomorrow he'll say, my AC stopped working, I had a green puddle on my garage floor at home, and I leaked out all my refrigerant, and I'll come back and there'll be no refrigerant. You have all those options. This is how leaks work. All right, guys, I see you.